As senior architects, we design these incredibly complex, resilient systems on Azure practically every day. We build for failure. But let's be honest, have you actually proven that your beautiful disaster recovery architecture works? Today, we're going to move beyond the blueprint. We're going from theoretical resilience to a validated, tested, and proven reality.
So here's what we're going to cover. We're basically going to run our own simulated DR drill. We'll kick things off by talking about the resilience illusion. Then we'll get into crafting the recovery playbook, automating the failover, and we're going to simulate a full-blown crisis. After that, we'll dig into the hard truths you only find during testing and wrap up with how to build a real culture of readiness. All right, let's dive right in. First up, the resilience illusion. This is all about that really critical, and honestly often dangerous, gap between having a DR plan written down somewhere and knowing for a fact that it's actually going to work when you need it most.
So you've architected the perfect system, right? You've got your geo-redundant storage, Azure Site Recovery is all configured, your traffic manager is ready to go. It looks amazing in the Visio diagram. But here's the thing. Until it has actually survived a real, or at least a realistically simulated failure, it's just a hypothesis. And in our world, a hypothesis is really just a theory that's waiting to be broken.
So your architecture isn't truly resilient until you prove it. And that's really the core theme for us today. The conversation for senior architects isn't just about designing for failure anymore. It's about validating that design under some serious pressure. So the big question is, how do we actually do that effectively?
So how do we prove it? Well, the whole journey from theory to proof starts with one absolutely essential document. And that brings us right to Section 2, crafting the recovery playbook. This is where we stop assuming things will work and we start documenting the exact steps to get from disaster back to recovery.
Look, this runbook is way more than just a document. It's your single source of truth when things go sideways. When the alarms are blaring at 3 a.m. and the pressure is on, you do not want your team guessing or trying to remember some complex sequence of events. You want them executing a clear, pre-approved plan. This thing right here, it eliminates the guesswork.
A really great runbook has 5 parts you just can't skip. First, the activation criteria. What specific event, or maybe a combination of events, actually kicks this plan off? Second, the communication tree. Technology is only half the battle. Knowing who to call, when to call them, and what to say is the other critical half. Third, the technical steps, the exact sequence of commands, scripts to run, and portal changes. Fourth, validation checks. How do you know you're actually back up and not just serving a page of errors? And finally, the rollback plan. How do you get back to your primary region once it's healthy again?
Okay, so having a detailed playbook is a huge step forward. But let's face it, a human trying to execute dozens of steps while under stress is a major potential point of failure. This brings us to Section 3, automating the failover. Let's talk about taking that manual checklist and turning it into something that runs at machine speed.
This comparison says it all, really. A manual recovery is going to give you a high recovery time objective, or RTO. That's just the time it takes to get your services back online. It's slow, and it is so prone to human error. But on the other hand, an automated recovery, using tools like Azure Automation Runbooks, gives you a very, very low RTO. It's consistent, it's repeatable, and it executes with a speed and parallelism that no team of humans could ever hope to match.
Okay, so we've got our playbook, we've got our automation. Now, it's the moment of truth. Let's head into Section 4, where we simulate the crisis. This is our planned drill, designed to put our documentation, our automation, and our team to the ultimate test. All right, the time has come. The war room is assembled. The monitoring dashboards, they all suddenly go red. The alert is confirmed. We make the call. Simulations start. Primary Azure region failure declared.
You know what? There's no panic. The team looks at the runbook. The first step is crystal clear, and it's not a flurry of frantic phone calls. Nope. It's a single decisive command. Action, initiate automated runbook. Someone pushes the button, and the entire orchestrated failover sequence just kicks off instantly.
So the automation is running, but the team's work isn't done. Not by a long shot. They immediately shift their focus to validation. As the automated steps complete, they start running through their post-failover checklist. Has Traffic Manager rerouted DNS? Are the SQL failover groups now pointing to the secondary databases? Are the app services actually responding? And maybe most importantly, can we process a key business transaction from end to end? Trust, but verify.
The simulation was technically a success. The system failed over. But here's the secret. The most valuable part of any drill isn't whether you pass or fail. It's everything you discover that almost went wrong. So let's move to Section 5, the truths found in testing. This is where we uncover those painful pitfalls you only find when you're under pressure.
These are the things that turn a 15-minute recovery into a 3-hour outage. A total classic is a Key Vault secret misconfiguration. The app fails over, but it can't connect to its database. Whoops. Another one is finding out your data sync lag means your recovery point objective, how much data you could lose, is way worse than what the business signed off on. You might find that DNS propagation adds 20 minutes of downtime even after your systems are ready. Or my favorite, you discover a third-party dependency you completely forgot about is hard-coded to an IP in the primary region. These are the golden nuggets of info that make testing so valuable.
Now, finding these issues is fantastic, but only if it leads to real change. And that brings us to our final section, building a culture of readiness. This isn't about some once-a-year fire drill. It's about weaving continuous testing and improvement right into the fabric of your operations. So, what does a mature DR testing program really look like? Well, first, you're scheduling these drills quarterly. The cloud moves way too fast for annual tests. You're testing all kinds of different scenarios, a single service failure, a storage outage, not just the big region meltdown. You're also getting application and business owners involved so they can see and validate the process. And most importantly, every single finding from a drill is treated like an urgent, high-priority bug that has to be fixed, not just a note in some report that no one ever reads.
And that really brings us to the final thought here. We all know an outage isn't a matter of if, it's a matter of when. So the only real question we have to answer is this. When that moment comes, is your recovery playbook going to be some theoretical document collecting dust on a digital shelf, or is it going to be a proven, tested, and validated process that's embedded in your team's and your automation's muscle memory?